This is my sambaXP 2022 talk about symlink races, and we had a big security release. I think it was 4.15, and a lot of rework of the VFS, and it was hidden behind all let's do it right and all efficiency stuff. And how do you do a security release when you have to rewrite the world? Andrew talked about this in his talk, and we had our own share of this. So the file server also had this big security issue that we had to hide for a while, and now it's all open and we have to deal with symlink races. The SNIA asked me to give this talk, or essentially a stripped down talk of symlink races and an introduction to symlink races. And SW told me, hey, explain symlink races to your mother. And that's what I try to do in the next 5 slides for anybody who doesn't know what a symlink race is. So why do we care about symlink races? And if you search in the CVE database for symlink race, the first thing you find is Trend Micro Antivirus for Macintosh could allow an attacker to create a specially crafted file and so on. So this is just the one, the top one on this list here for whatever reason. But what you see is symlink races are, there is 1,354 symlink races just in this simple search. So what's going on here? And yeah. And the way I describe this to SW, or rather my mother, is I make up an example. And what I want to do is I want to export cat photos to my blog. And I go to Nautilus and I see little cat photos here. And what I then do is I can see, do you see my mouse, by the way? Probably.
Yep. Yeah, we do.
So we see that in my home directory under photos, pets, cat, there are 2 photos, and I put this path, photos, pets, cat, into my browser to upload it to somewhere, to some website. And my directory hierarchy completely looks like this. And I have a photos folder, and I want to go to pets. I have my dog, I have my cat, and I have a photo01.jpg. But I also had an insurance case with my car lately, and there I also have 01 and 02. And I want to publish the blue JPEG file. So this is my blue JPEG file. This is not my cat, by the way. I'm allergic to cat, but I just like these photos. The steps taken to publish this cat photo. I browse my directory hierarchy. I figure out the absolute path as a path name, and this is important. So I have /photos, /pets, /cat, /01. I paste this into my browser, and then a few seconds later, I press upload. And in these few seconds, somebody else on my computer, and I mean, that's what always happens, somebody else is doing something on your machine. There's a few seconds for an attack. And this is the typical time of check, time of use thing, that I check, this is my path, something happens, and then I press upload and I do something. What happens is that the attacker replaces the file 01.jpg with a symbolic link to the latest communication with my insurance. And the Unix command would be ln-sf, and it replaces 01, or it replaces my cat photo with a symlink to a photo of my car. And this is what actually gets published, because at this press upload time, I don't recheck. And if I just rechecked, there would always be some a few milliseconds where something bad like this symlink can happen. And so this is what it looks like. My directory hierarchy has slightly changed, and this 01.jpg as a file has been replaced with a symbolic link to a different path in the directory hierarchy. And so this happens between I type photos pads cat 01 into the browser, and between the moment when I type it in or copy and paste it or press upload, this symlink happens. And what instead gets published is this photo. And well, this could have been your passwords, docx. And I know people who have passwords in plain text in their somewhere in a passwords docx. And so this photo is a bit embarrassing, possibly, but it's also from Wikipedia or somebody on the internet with a good license to publish this. But this didn't happen to me. But still, the attacker could have published your passwords your passwords file with all your Amazon credentials and all that stuff. Okay, what do we do about this kind of attack? Let's go back to the change here to my directory hierarchy. And what happens here, and we'll get to the difference later, the last component of the file name, the filename 01.jpg, is being replaced with a symlink. And Linux can protect against this kind of attack, and by adding the oh no follow flag to the open call that ensures that 01.jpg is not a symlink. Let's read the man page here. If the trailing component, i.e. the base name of path name, is a symbolic link, then the open fails with the error eloop. When using oh no follow, the upload function will get an error. I mean, it won't upload anything, but I will know that something else happened. However, the man page also mentions that symlinks in earlier components of the path name will still be followed, which means if a symlink is happening in pets or in cat or even in photos, this will still be followed, although I put in the oh no follow flag to the open call. And this is the different attack. So now what happens is that the attacker takes photos pets cat and replaces the cat subdirectory name with a symbolic link to car. And if you remember, I wanted to publish photos pets cat 01.jpg. And what actually gets published is photos insurance car 01.jpg. And well, this could also have been your password stock file. What do we do against this one? And this is what Samba right now does in many places. Essentially, what we do is we do a full change here. We switch into the directory photos pets cat. Then we make sure, and we'll get to the details of that later, that we actually are sitting in what we intend to be sitting in, namely photos pets cat. And that in between our change here into photos pets cat and our checking, nothing bad happens. So I check that I'm really in photos pets cat. What I then do is I do open of 01.jpg with oh no follow. And because I don't have any path components but the last one, this actually helps. So we have 4 steps here. We have changed here photos pets cat. We do an expensive check that I'm really there where I wanted to be. Then I open the file with oh no follow, and then I change the back to wherever I came from. And now let's look at what happens when the attacker does the same thing as he did here. So change here, do the check, open and change the back. It moves me together with, the file name. So I do the change to cat, and now I do the check. And because I'm sitting here, I'm sitting in the subdirectory, and if the check told me that I'm still in cat, and in between this check and when I actually do the open call, I get moved, it doesn't matter. Because it still references the correct file because I am moved somewhere else together with the directory. And yeah, this is the way that Samba most of the time these days protects against this kind of symlink race. So there's better alternatives, because this change here and then do the check and so on is very expensive, and doing it on every open, is slowing down things. There's better alternatives, and in POSIX we have a family of syscalls, the so-called add-based syscalls, and what this does is we don't have to change here into this cat subdirectory. What we can do is we can open it once and then utilize this number 42. This number 42 is a file descriptor. I mean, it could be any number. But we open the directory and we keep this number 42 forever to really reference the subdirectory cat that we did check properly. So we do these four steps. So change the into photos pets cat, make sure that we are actually there, then do an open to dot, open the current directory, and hold this reference. So we can then kind of cache it. For how long needs to be decided upon, that's another story. But what we can then do is we can do this cheap open add call, referencing the subdirectory that we opened and held as a reference. We can reference this subdirectory as this number, and then relative to that subdirectory, open the file o1.jpg with o-no-follow, and we are also done. So this is where we need to go eventually, that we do this always, and do these expensive checks. And what these checks look like, I'll get to it in a few minutes. Do these checks as few times as possible, and then always reference directories with file handle numbers. And when we then do path-based operations, name-based operations, we need to make sure that we always add this o-no-follow flag. And as names, we never pass subdirectories. So our file names that we give to the kernel should never ever have slashes in there anymore, because then you always get the problem of symlink races, the symlink race where the cat was replaced with car. Okay, what are symlink races from 30,000 feet? And let me look at the chat. Any questions so far? No questions so far. Okay, so symlink path names in POSIX are essentially.
Volker, I have a quick question.
Yes.
Sorry to interrupt. When you're chasing the paths above cat, do you perform those same checks? Like when you move through pets, do you perform the check that pets wasn't replaced? Or do you only have to do it at the terminal directory in the path links?
So what we do is essentially we go to cat, and I'll get to that in a minute, and then we do a real path. And this uses the get current working directory syscall from Linux, which gives us the prefix. And we compare that with what we believe to be in.
Okay.
So we do it in one run, essentially.
Got it.
Okay, path names in POSIX are prone to input validation problems, and they are a time of use problem. And sanitizing these paths is possible, but it's a lot of work, and so nobody does it. And even the secure Rust project, in their, I think it was in Cargo, in their package manager, they have symlink problems. So what's the current status with Samba 4.16? I mean, in particular, Jeremy and Ralph did a lot of work changing our VFS to move it to these numbers here, to move it to file handles for directory names, and then do all these add-based calls, not mentioning any path names anymore, any path components anymore, but the last component. but yeah, we need to do more of this. So many places in Samba now have to do this change dir check open change dir way because we are not done passing directory handles everywhere. And this check is encapsulated in the function non-whitelink open, and this is really expensive. And we are working to pass directory handles everywhere. Linux is working on making this easier. For example, they have added an openet2 call, and there you can pass a flag resolve no symlinks, which fixes this, however, in the oh no follow man page. Which means that when you use openet2 instead of openet, and you give it the resolve no symlinks flag, then no symlinks are allowed anywhere in the path name. And so this will be a very quick way to make these checks unnecessary. And when this then fails with an error message, you can do your expensive work. So the quick one will be do the openet with resolve no symlinks. And yeah, there's another thing that I believe have read about is that we have a mount option somewhere. I'm not sure that's actually in yet, but there's a mount option for file systems that might disallow symlinks overall. Maybe Steve French can answer this. So yeah. Okay, now to the problem. And this, by the way, was the piece explained to your mother. Let's look at the chat. The mount option is in. Jeremy, how long can the directory of FDs be cached? If a directory gets renamed, they probably need to. Yeah, that's one of the problems. Christian asked, how long can the directory file descriptors be cached? If a directory gets renamed, they probably need to be invalidated. This is ongoing discussion with Ralph in particular that I'm talking to, or who I'm talking to, and the question really is how bad can things go? I mean, this directory that we got the file descriptor for used to be inside of the path at some point in the past. And if that then gets moved out of the share, well, you could argue that this can't be that bad. It used to be correct, but I mean, this is you don't get atomic creates really with POSIX, and the question really is how much of a window will you allow? And Jeremy says, yes, this mode option is there. I'm going to talk about this shortly. Yes, good. Okay. Samba 4.16. OEMs came to us and complained that all these changes are already in 4.15, that 4.15 is slower than 4.12. Benchmarks like SpecSFS software build do a lot of stat opens, which means that the client only wants metadata. And this is really a bad workload for us because our open code is doing multiple syscalls. The close is also doing multiple syscalls, but it's a very popular and important workload to have. And so when I do just an open of ABCDEFGX.text, and this is really what happens with SpecSFS software build and other benchmarks. When you look at the S-trace, and I'll do this in a minute, the 4.12 has 30 syscalls for this, I mean, which is also quite a lot. But 4.16 gets a lot worse, almost twice as many syscalls, and we'll take a look at what this does in a minute. And 4.17, I mean, this is master essentially, we could already strip this down again a bit to 43 syscalls. And yeah, I'll get to that lower. Now can you see me switching to Emacs here? Do you follow me here?
Yes, we see it.
Great. So these are the S-traces that I was talking about. And if Martin's talk was a geek talk, this is really a geek talk. So what is this? I opened strace, I followed an SMBD, I went to my SMB client, and I did this call just opening that path, ABCDEFG, x.text. And what's going on here? What we first do is we stat, does it exist? Well, yes, it exists. We don't get an error here. What we then do, and this is kind of surprising, this is the call to the Linux function real path on ABCDEFG, or rather go one further down. So we do the real path on the whole path name while sitting in temp. And if you look at this, I mean, this does a lot of syscalls for each component. And if you have really a lot, I mean, path handling in Linux is really blindingly fast, and there's not many as optimized code paths as path handling in Linux. But it is, in theory, it's O to the order of n squared. If you have like twice as many path components, you have to look at at 4 times path components in the kernel, because the kernel again and again and again and again has to look at A, B, C, D, and so on. So this is an classic O to the order of n squared, and this will get expensive. And the other thing is, I mean, we don't really rely on this anymore, but what happens if between these two syscalls, somebody changes B? Does the real path implementation work with this? And does it bail? If somebody inserts a syscall for this B to somewhere else, I don't know. So what we do then is, essentially in 4.12, we had all our symlink race problems. We do absolute, we do name-based calls with all these path components in between. And yeah, this is where the symlink races are. Whatever happens in between, this could be your etc password.txt, your passwords.txt. It's not really that bad, because when we actually open the file, and the open call is here, before we actually open the file, we do our little dance that I described to Tom. We do a change dir into the target directory. And then essentially what we do, and this is the real path thing, we rely on the Linux kernel to give us the current working directory. And we rely on the Linux kernel for this to be correct. And we then check this, hey, did somebody play tricks on us and move us out of the subdirectory? And then we do this open at with o no follow. But so this is, we are not fully broken, but this is just the open. But I mean, as I said, there's many other calls that are prone to these symlink attacks around this. But I mean, it's fast. Another getEx error. It could be that we reporting extended attributes for a completely different file during this. Let's look at 4.16. Same thing. We do this real path on the whole thing, but we don't really rely on this, because we do a change dir into the subdirectory, and we do our, and now comes the opath thing on modern Linux. I mean, modern as of like 2.6 or something. So we check the path. We make sure that we are in the correct subdirectory by this getCW, CWD call. We compare this with, is this really under the share? And then we do an oh no follow open on the current working directory of the non-path component, or the just last path component, x.text. So what comes next? Wait a second. So we have opened our x.text. file descriptor 9. Fine. But then we do this whole dance again. See. Oh, sorry. We do the change dir. We do the check again. And then we open the current working directory. Why does this happen? And let's look at the 4.16 source code. Source 3, smbd open.c. It's in the function create file Unix path, parent pathref. Here you go. Get a reference on the parent. We can reuse this for multiple calls to check parent echoes and so on, to avoid path name calls. Yes, this is very helpful for the code structure, but for this workload that we were tested against, it's kind of a performance penalty, because for this one, we don't need this. We don't need any of this for this particular case. But this is done on every single open, and that hurts us. So coming back, we do our real path check. Yes, are we still in subdirectory G where we wanted to be? We change here back to the share root in this here. We do some more checks, and we do this again, and this really, really hurts. And what we did in 4.17, or rather master, we removed this call. Okay, where are we? This now looks a bit different. So what we do is, remember we were opening, let's go back to the slides. We were opening ABCDEF G and then x.text. So we essentially need to reference G as a subdirectory. And this is what we are doing here in 4.17. So we change into the parent directory of G, which is F. And that is the pattern that we need to do everywhere in the future. So we change into F, we check that we are actually in F, then we open the subdirectory G of F, which is the parent directory of where we actually want to go, which is the parent directory of our file that we want to open. And we know that's my 42 here. This number 9 is my 42, because I opened this with oh no follow. And this is my 42 that I can now utilize to open my file that I actually want to open, that I really want to open. And remember that in 4.16, we had to do this complete dance with change dir, check, and open dot, just because we lost the information where we were. And what we are now doing is we are doing this just once. We open G, and we use G, or rather the 42 here, we use the 42 or 9 to reference it very cheaply, and yeah, do this oh no follow x.text open call. Okay, and this is the one non-white link open call that comes from create file Unix path. So, and this is essentially the pattern that we need to follow through, that we need to apply everywhere, essentially. And the way I approached this was I just looked at this at strace, and if you, for example, want to delete a directory, I mean, you really get eye cancer, because there's so many calls to non-white link open on deleting a directory. We open the parent and look for delete child. When setting delete on close, we need to check whether the directory is empty. Yet another one where we do this non-white link open. Then for close, and this is particularly bad, we need to do a parent path ref again, because if you remember Ralph's talk, we never do full, or remember the last slides, we never give full path names to our syscalls anymore, but we only ever get directory file descriptors that are actually checked against the share path to our syscalls. And unlink@, is one of these. So to remove a file from a directory, which is referenced by @ we need the directory, and we need to check it. Yes, and in each of these steps, there's one or more non-white link open call, which are expensive, and there are really many cases like this. So what are our next steps? We need to replace filename convert with filename convert DFSP, and this is the base of our change in 4.17. And look at the patches or contact me what this exactly does. But essentially, this is the function where we hold on, we create this number 42 together with a handle on x.text. Excuse me. And then we need to pass this directory file, directory FD essentially through as many callers as possible. An alternative, and this came to my mind when looking at this close call, we could just store on every file handle that we have, we could just store the containing directory as a file descriptor. I mean, this is expensive because we really don't know how long this is going to stick, but this is the only way essentially to avoid having to do this pair on path on just for unlink @ again. So the problem here is that a directory file descriptor is rather heavyweight. Just our structure for holding this is 344 bytes. We have some structures hanging off this, so I would just imagine that we are at 1 kilobyte per open file of RAM. So this needs to be well considered. So we really need to go through all calls of filename convert. And there are many callers of filename convert. Synthetic pathref is one, parent pathref is another one. And when we are all done with this, or as part of the work, what we could also do is we could eliminate essentially the requirement to do a change dir every time. Change dir into a subdirectory, change dir back to the share root and so on, which you have seen in the syscall, in the straces. We could eliminate this by really holding the share root that we have as a directory handle. And so use this as an add call for all operations. So I think that's about, these are the little tests I want to show you. But let's in the meantime look at the chat here. 15 minutes left. It's the getX address that can be raised. Storing root FSP is something I wanted for a long time. 10 minutes left, but Alexander's talk is not happening, so I have 1 more hour, I guess. Whatever. Yes. So I have a few little tests about how we can speed up this filename convert, and I want to show you what we should do. I have created 3 little test programs that show hopefully an impressive speed comparison and what we could do. The first one is test change dir. So this encapsulates in a little test program essentially what we are doing. And just for simplicity, I have this subdir, 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 and so on. I have this directory. And this is essentially what we are doing when trying to open a file or a directory in a safe manner. We grab our current working directory. We do the real path on the full path, which kind of doesn't make sense anymore, but we do it anyway. This is the l things, the O to the order of n square ones. Then we, as part of our stat cache, we do 2 stats. we change here and we do a real path, and this is the real check. What I have in blue now is this is our safety guarantees that we do a change here and we do a real path on the current working directory, and somewhere in here, check against share root. Somewhere here, we check what we have against, yes, we are still under the share root. And then we do a directory open on dot, whatever we open there. The important piece here is the owner follow. Let's look at the speed that gives us. By the way, I just do this in a loop, and once a second I print how many of those I could do in 1 second. Very simplistic. The first test will always be faster. Test change here. Okay, let's see. On my laptop, we can do roughly 43,000 of those, which is, count the number of milliseconds and so on. The absolute number is not important here. Next step that we could do, and this is important for proper symlink handling, is we could just walk the subtrees with open at the next level, use that as the directory file descriptor. So this would walk the steps, this would walk the subdirectories step by step, all of them with owner follow, using the next file descriptor as the add file descriptor for the next step. This would also be a safe alternative. And let's see. Let's just do the strace of this. Strace test open at. This is of course slow, but that's the strace. I want to show you the number of the syscalls that this looks like. So we open the current working directory and we just play ping pong. We open the first subdirectory, we get a 4, we close our root, we open the second one, we get a 3, and so on. And just imagine A, B, C, D, E, F, G, and then x.txt. I was just too lazy to encode this. And now let's look at the performance of this. Remember 46,000. The point is, this is even better. And it's completely safe. And I mean, these are not 100% reliable. I have a laptop. This is in a Hyper-V and so on. But it is in the same order of magnitude as what we do now. The point here is, and I have this in my slide, this is the path to proper SMB2 server-side symlink handling. So what we need to do when we do proper SMB2 server-side symlink handling, we need to send, so we get A/B/C and so on, and somewhere in the middle, there's a symlink, and the SMB2 protocol requires us to tell the client, hey, there was a symlink, but I could swallow n bytes of what you gave me. So we have to tell the client where the symlink was. And we don't get any of this with our first approach with real path and so on. We just get told by real path, hey, you're somewhere else. But nobody really tells us where the symlink was. And if we do this open at close thing, we can exactly tell where the error message is. By the way, in this slide, I forgot the owner follow. But I have it in the code. So we need to do that anyway in one way or the other, and this is the safe way if we want to report server-side symlink errors. And just to show what we do as a good case optimization, I mean, this completely blows everything out of the water. This is the open@2 syscall. It's not in glibc, but syscall number, there's a define somewhere in user include Linux. I just picked the 437 out of user include Linux. And this is essentially the open@2 call that tells me don't allow any syscalls anywhere in the path. And what we would do is replace filename convert with this call, and only when there's an error, do the expensive dance. Maybe with open-add, then whatever, get real path name and so on. But only if this fails, do this expensive dance, and let's see how fast that is. I mean, this is essentially just open, close, open, close. There you go. I mean, factor of 10 roughly. And yes, send it to the client to resolve. Also, correct, FreeBSD doesn't have open. FreeBSD might, yeah, let's look that up. FreeBSD might have a similar flag for open-add, possibly. But the point is, don't allow any symlink anywhere in the path that we give to open-add. And yeah, hope for the, and then do the expensive stuff when there is a failure. Thanks for your attention. Are there any questions? How am I doing time-wise? 4 minutes, 3 minutes, and probably just another hour. Thank you, Jeremy.
What happens if syscall 437 is not present? It's an error.
We will deal with that. I mean, it will probably give us eNoSys. I mean, this is just the fast. This will just be the fast path for the good case, and we have to have the fallback anyway.
That you're running on a system that has that support.
I mean, we can, of course, if we detect once and forever that this syscall is not there, we can just not call this. I mean, we have quite a few of those checks somewhere. For example, for X-address, if we are sitting on a file system that doesn't have extended attributes, we never call extended attribute calls anymore.
Yeah.
We tried once, and if we get an eNoSys on that, we don't even try anymore, and we do the expensive fallbacks anyway. And yeah, I mean, we have to have the expensive, the multi-step fallback in case there is a symlink somewhere in between anyway.
Yuck. So you've got to keep and test all that hideous old code that was vulnerable with your patching. Yuck.
Not really. I mean, what we really want to do is, or what I want to do, and this is kind of opening it for discussion, I want to do essentially this one here. So this dance of open these subdirectories in lockstep. And I mean, to speed this up, we have IO uring. We could send essentially all these closes into an IO uring and hope for the error somewhere in between. And I need to talk to Metz to tell me how to reference these, to send all of these send all of the open ads into an IO uring so that we save syscalls.
Oh my God, then, an enormous parallel open at.
No, it's sequential because this one here depends on this one, but you want to save the syscall.
I see. Yeah, okay. So it's not parallel, but it's heavily batched, I guess. Okay.
Yeah. But this is, it's batched, but it's not really parallel.
Right.
And this is why I think, is it worth it? I don't know. I mean, the closes definitely. We should send them into an IO uring. So we save these syscalls and then defer them to later. Because I mean, this is all no follow or path handles. We don't really care. We have no locks on these. We can't have any locks on these. And they are cheap. They can go away in a millisecond later.
And in fact, they could be parallel.
Yes, of course. These closes can then be parallel.
The opens can't, but the closes can. So
just send them to a worker thread in the kernel. So we should even be faster with what we do now.
Yeah.
Yeah, I think the current code in the kernel doesn't allow the call chain for the opens because the fixed files are not able to be passed into the DRFD parameter yet. But I guess it's just a matter of time. that the kernel will get that.
On the other hand, I mean, maybe we could even ask for an error message. I mean, what we really need is from the open@2 call, where is the symlink? That's what we really need.
Testing, testing. Hello? Can anyone hear me?
Jeremy, you're...
Oh, sorry. I wasn't sure my audio was working. The only issue with the open@, with the following the path name and returning symlinks to the client is if someone has put an absolute symlink that points within the share, the client will be able to follow it. But you know what? I'm absolutely...
Yeah, I don't care.
Yeah, exactly. I'm absolutely okay with breaking people who've done that.
Exactly.
And saying, go fix your symlink to be within the share. Sorry, we don't support that anymore. I think there's a time and a place for saying, nope, that's legacy, we're not doing it.
Or, I mean, we will still support follow symlinks and white links. We will have to support this for a while. But this should never be the default path anymore.
Sure, that's why there's a separate module for that.
Exactly.
And the other thing, the Linux kernel folks got lazy when they say, there's another flagged open@2 that basically says only do things below. And that system call fails if it's an absolute path. If the symlink path starts with /, even if it points below, they still fail it. They fail any symlink that starts with /. Because they're lazy too.
Yeah. But then everything will be void because you remove symlinks from the kernel, right? Jeremy?
Well, you just kind of did most of my talk already, but I'll try and find something. No, your talk was better, and I love your demonstrations. I love the cat pictures too. Upload, that was great. So I'll try and find something new to say.
Okay, you have an hour.
Yeah, we never saw your damaged car. We felt bad for that.
Yeah, I did some picture search on Google for accident, and these came up with a good license.
And maybe just to clarify, because Tom, I wasn't sure if you weren't having the impression that this is discussing options for making the code secure, because this is actually not differing options for making the code secure.
Right.
Because
it's
that's what we already had. Right?
Yeah, the efficiency of the implementation.
No.
Yeah, understood.
Okay, great.
Yeah, it's just sort of follow-on work. You know, how do you keep tweaking and tuning to improve the performance? And Volker was exploring how to do that with the U-ring.
How do we avoid users and vendors sitting on our back and complaining, "Hey, Samba got slower. What did you do?"
Yeah, I mean, I guess that's a question. What if you weren't concerned with this type of attack in your environment? Could you turn this off and go faster? I mean, I know
unfortunately not.
Yeah.
I mean, we were considering this for a particular OEM on Fuse, and Fuse is particularly bad in syscalls. And this is, I mean, Jeremy is here. We were discussing this to essentially go into non-white link open and have an option. So we have this non-white link open. Where are we? Sorry.
Yeah, I mean, it's always dangerous to have a big knob to turn off a secure function. But
yes, I mean, this is, so just add an option here to not do any of this, but rely on the whole thing.
So I think my understanding is we actually have this option to turn off the security check, but the thing is,
it doesn't turn
off the security checks. It just turns off using the result from the security checks.
Exactly.
Right?
It still goes through all the work, but then ignores the result. I see.
Yes.
Yeah.
So here we are.
Probably change that. We could probably change that.
Yes, that's one of the options, I guess, that we could look into.
Can we have that in written, Jeremy?
Oh no, sure. I never objected to that. Yeah.
Jeremy, would you like to be published in the register saying that?
There you go. I wrote it down. No, I mean, if an OEM basically says, "I guarantee I have no symlink races," then we're just getting in their way.
Mm.
Yeah, that's the point.
But how many of them are just going to lie to you?
Or not know they're lying. Yeah.
Well, yes, there is also that. Anyone who exports NFS at the same time as SMB cannot make that claim.
So I mean, well, we had a customer that said that they actually make changes in their file system to ensure this, right? So I mean, it's possible that they don't know what they're talking about, but in that situation, I tend to believe them and would prefer not to give them the answer like, "Oh, go away! You're probably not knowing what you're talking about."
If they have their own file system, I'll believe them.
Well, yeah, if they implement the entire thing in the kernel and they can share that state with reference counting and locking, etc. But bouncing in and out of user space like SMBD has to do, that's going to be a real challenge, kernel or otherwise.
And Tom, I just want to point out that one of the early issues we found with KSMBD, I don't know the Namji's here, is that KSMBD could also be symlink raised.
Indeed.
So being in the kernel is not a magic bullet.
Yeah, as I peeked ahead in the schedule, and as you say, it's been like this by design since Berkeley thought it up, right?
I'm going to get into that, but there may be shouting involved.
We love shouting.
So that's basically it for my talk.